I apologize for white mode, folks. Today we don't have dark mode today. We'll try to see if we can complete it in an hour and a half. And then doubts. This is very abstract class, and I've structured it in a way. Okay, I had an interview with an L2 once. L2 stands for Layer 2 protocol, EVM based Layer 2 protocol, and the questions that they had asked were like in depth of how Ethereum works, considering they were also building, something like Ethereum. They were building an EVM chain. So everything that sort of would be expected in an interview like this is something I'm going to talk about. I did not want to dive into too much detail, but I thought some of you at some point may interview with one such L2, so it might help this knowledge here. How does Ethereum work under the hood? Usually when you're writing contracts, you wouldn't really be, focusing on these details. This is like if you're learning the MERN stack, but I'm teaching you how JavaScript gets compiled under the hood. How does the browser run it? How does the browser interpret the binary, things like these? Or if you're learning Rust, we try to deep dive into the binary and understand what low level opcodes are running, things like these. That is what today's class is going to be. If you look at the syllabus, the syllabus is on blog.100xfs.com. The first part of Web3, this is what we're covering today. What is Ethereum? We will not cover proof of stake, probably don't even have to cover it, but I can create a video if need be. The real things we will understand today. I'm hoping already some of you know what Ethereum is, at least high level. Ethereum is another blockchain. We have also talked about it a few times. We'll understand the architecture of EVM, the Ethereum virtual machine. We'll understand how is state stored in Ethereum. It is different from how state is stored in Solana. वो चीज़ हमने Solana में कर ली एक बार. Solana has a very weird data model. The biggest sort of learning curve in Solana is the data model. We have done that. Much easier in Ethereum. That is what we'll discuss today. We'll understand what is bytecode for the people who are coming from the Java world. You probably have heard of bytecode and opcodes. ABIs, which again isn't Ethereum specific, happen in Solana as well, but we haven't discussed them in Solana. We can discuss them there as well. We will probably not be doing transaction parsing today. We'll understand gas, externally owned accounts and contract accounts. Isko chhod ke 2-3 more things I've added, but high level, these are the few things we will cover. What time is it? It is 8:05, so I think we can start. Again, as I said, try to wrap it up in 1.5 hours. It is an abstract class, theoretical class, not a lot of implementation. वैसे तो if you guys are smart enough, which I hope 100x devs you guys are, so if you know how a wallet adapter works in Solana, you should start to dabble with how a wallet adapter works in Ethereum. How can you run Ethereum on the server? Just like there is web3.js, there is ether.js, and how does ETH work with React and Next.js? So I'm assuming these are like fairly simple things that we can cover, very quickly. This is the hard bit because number one, I'm sure not a lot of you have dived into this architecture. Neither did I till my L2 interview. You don't have to dive into these architectures unless you are interviewing for a blockchain itself, or want to work at Solana, Ethereum, or there are like tens of blockchains that come and raise money if you want to work at one of these blockchains. So I'll start with a poll. Okay, how many of you already know this? Give me a yes or a no. Usually the number is 30 to 40% already know this. Do you already know this? Yes or no? So it's today 20, 25, 20% know this and 80% don't. So sort of similar to what I would have expected. And as I said, abstract class, so no coding at all unless you want to write some contracts, high level stuff. We'll try to see how deep we can go. If we have questions, we'll do at the end. Without any further ado, let's understand with some slides, which take a lot of time. So you're welcome to prepare. We'll not go through Notion docs for Web3 at all. I think Notion docs get a little overwhelming for Web3 people is what I've heard. We are writing notes, but all classes will most probably be via slides. With that, today we will first recap what is a blockchain for people who are just joining, or generally before we get into the hard bits. Let's recap what is a blockchain. Then we'll understand a little bit about Ethereum and the world state in Ethereum. Ethereum as a state machine. This is a term you will oh shoot, I forgot to I'm recording, my bad. And is the audio device right? It is wrong. What's going? Audio capture 4. Road mic. There we go. Hello. I apologize. Yeah, there we go. Cool. We are going to recap what is the blockchain, understand the world state in Ethereum. What does it mean when I say Ethereum as a state machine? Why do all smart people, you'll keep on saying, we'll make our own state machine. Types of accounts in Ethereum, externally owned accounts and contract accounts. On Solana, if you remember, high level, there were 2 types of accounts, the normal accounts that we had and the program derived addresses. These would store state, data, owner, things like these. Ethereum, it is very different. So what are these two types of accounts? Physical machines versus virtual machines. This is more of a Web 2 concept. But before we dive into EVM, Ethereum virtual machine, or try to understand a little bit about the Java virtual machine for the people who are coming from the Java world, we'll understand what exactly is a virtual machine. How is it different from physical machines that we have? If you might have started an EC2 server, you keep on saying, I'm starting a virtual machine. So what is a virtual machine? How is it different from a physical machine? Various Ethereum clients, believe it or not, if you are ever wanting to start, an Ethereum miner, if you want to become an Ethereum miner yourself, earn some Ethereum by, doing proof of stake, there are various codes that you can run. Like a lot of smart people write the Ethereum client themselves. Same is happening for Solana. For the people who have heard of Firedancer, which is another Solana client, this is something that comes from the ETH world where Ethereum has a lot of clients now. It is a very important concept when it comes to decentralization. So we'll understand that. Then we'll understand Solidity, bytecode, ABIs, and opcode. This really is the high level important things to know if you ever go into a low level interview in Ethereum. And architecture of EVM, what is memory, storage, and contract. Basically, we'll dive into the Ethereum virtual machine and understand if today you become a miner, what exactly is your code doing under the hood. This thing that I've written, ETH clients. You will run one of these clients on your machine. What exactly is that client doing under the hood is what we'll understand here. That's a high level. Let's get right into it. Starting off with the simplest things, recapping blockchains. You guys already know this. I'm sure some of you are rolling your eyes. Why are we learning this again? Very quick 2-minute intro. A blockchain is a decentralized distributed ledger technology that records transactions across multiple computers in a way that the records cannot be altered without gaining access to more than 51% of the network. We discussed this in the very first class. Why do you need a blockchain? What does it actually solve? I hope by now we know there are few things that can only be done through blockchains. For example, if you want to hold a lot of US dollars in India, you can buy USDC. The reason you can buy USDC and not be worried about the government is because the government, well, this is not technically true. The government can ban USDC in India if they want, but as you can see, it hasn't happened until now. Blockchain is one technology that lets Indians hold US dollars in the form of USDC tokens. So these are things that you couldn't have imagined could have happened before blockchains were there. You could have held some cash in your house of US dollars, but the government can always come and seize it. But right now, one of the biggest use cases of blockchains is what? Letting HNIs, high net worth individuals, hold this asset that a government cannot block. Sometimes that asset is Ethereum, sometimes that asset is Bitcoin, sometimes that is USDC. If this is the world map, which is an ugly one that I just created, what exactly is a blockchain? A bunch of machines, a bunch of miners all around the world that are constantly running some code. The Ethereum client that I talked about a while back. All of these miners are running some code, and this code maintains something called the state. These machines are all talking to each other and trying to calculate how much Ethereum does Harkirat's address have. And if I send, let's say 0.1 ETH to Akash as bonus, let's say, Akash, what do you say? Then Akash has 0.1 ETH now, and I have whatever, let's say whatever ETH I have minus 0.1 ETH. All of these machines all around the world are constantly calculating that, constantly parsing and executing transactions. So if this is me or a user out in the world and I want to do anything, send 0.1 ETH to a friend, what do? I sign a transaction using my private key. I'm not going to talk too much about private keys here, but I hope some of us understand if you ever want to hold Ethereum, you have to hold a private key. And whenever you send a transaction, you sign a transaction using your private key. I sign that transaction, send it over to a few nodes. Now, what happens from here is a little different in Ethereum and Solana. Ethereum has this concept of a mempool, if you might have heard of. Don't need to worry about it just yet. But in Ethereum, what happens is, if I send this transaction over to some miner, it might happen that transaction gets executed after 5 hours or 10 hours or 20 hours. It sits in what's called a mempool, and it can get picked up later on as well. If I do not incentivize the miner enough, अगर मैं miner को enough Ethereum नहीं दूंगा कि 0.1 ETH to Raman, and you can also keep 0.01 ETH. If I don't tip the miner enough and a lot of people are transacting on Ethereum right now, तो मेरी transaction कोई उठाएगा नहीं. No miner will pick up my transaction. It will stay in the mempool. But whenever they feel like, okay, now no one else has more tip than Harkirat, so we will take Harkirat's transaction and process it. Harkirat is giving us a tip of 0.01 ETH, let's say. So you can send transactions. What happens when a transaction is sent to a miner? Do you remember from the Bitcoin days? What happens is a bunch of these transactions get grouped together into what's called a block. And then this block is what gets distributed over to all the nodes. That this specific block has been accepted. Harkirat has transferred 0.1 ETH to Akash. The world state that I talked about, and I will introduce again very soon. The world state changes. World state kya hai? Think of it like an object which has Harkirat's balance and Akash's balance. After this block is accepted by everyone, the world state on all of these blocks changes. All of these blocks have 0.1 ETH for Akash and some Ethereum left for me. So that is how blockchains work under the hood. Now, for Bitcoin, they do proof of work. If you remember, whenever you create a block, you have to do some work. And then when you find a nonce, if you remember, then that nonce is what lets you say, okay, I am going to propose this block. In Bitcoin, the way to propose a block, for example, if I have created a block here and if I want to propose it, there is something called proof of work that happens. If you remember, in proof of work, we are calculating a number. Ethereum used to be on proof of work, is now on proof of stake. So it uses a different consensus algorithm. We will not dive into that consensus algorithm today at a high level. The way Ethereum ka consensus algorithm works is every miner that is there needs to stake some Ethereum, needs to put up some Ethereum. Ye raha 20 Ethereum that I'm putting up, or 50 Ethereum that I'm putting up, or 100 Ethereum that I'm putting up. You have to put a very big number. 20 you cannot put. You have to put at least X Ethereum or more. अगर मैंने बहुत ज़्यादा इथीरियम स्टेक किया हुआ है, if I have staked a lot of Ethereum, then I will be the one whose block will be picked. I will be able to propose more often than someone जिसने 0.1 ETH, not 0.1 ETH, but let's say 100 ETH stake किया हुआ है. If this person has staked 0.10 ETH, this person has staked 100 ETH, I have staked 1000 ETH. So I will be able to propose the block more. I will be able to be the block leader more times compared to other people. So in Ethereum, the amount of ETH that you stake represents how often you will become the block proposer. In Bitcoin, how big of a machine you have decides how often you will propose the block. Why would you want to propose the block? Because आपने अगर block propose किया है, if you have proposed the block, then you get some Ethereum that the users tipped and you can keep it. That is why miners, people keep saying during bull runs के miner बना लो भाई, I have a mining rig over here, because that mining rig is constantly grouping these transactions. And in case of Bitcoin, solving a problem. In case of Ethereum, you may become a leader of the transaction if you have staked a lot of Ethereum. So that is how proof of stake works. And we can dive deeper into this later as well. Today, we are not understanding the consensus algorithm. We are understanding what happens under the hood when you are proposing these transactions. How are these transactions executed on the Ethereum virtual machine? So a blockchain is a bunch of these blocks, one after the other. There was first a genesis block, the very first block. क्या अब blockchain start हो गई है, and since then thousands of blocks have been added as Ethereum has grown over the last 10 years. तो पिछले 10 साल से there are thousands of blocks now. If you start from the first block and keep executing all of these blocks one by one, then you can reach the current state of Ethereum as well. That is sort of what happens when you start a miner. If today you want to start a miner at your house, you will do one of two things to sync your state to reach the same state as everyone else in the Ethereum network. You can either process all the blocks since the beginning, or you can do something else. You can take some sort of a snapshot and then go from there. But either way, ये blocks अगर आपने सारे one by one execute किए, if you execute block 1 where I sent some money somewhere, and then block 2 and then block 3, then you will reach the same state as the current Ethereum network. Here is a screenshot from Etherscan. You can go here as well. If you go to etherscan.io, you will see this on the landing page. It shows you a few things. What is the current price of Ethereum? What is the current market cap of Ethereum, which is the total price of Ethereum into the total amount of Ethereum that currently exists. And over here, you will see a section called latest blocks. So this is the total number of blocks that have been mined until now. Can you see this block has 206 transactions inside? This block has 206 transactions inside it. So Here I created a smaller picture. Okay, the block 1 only had 2 transactions, block 2 had 3 transactions. In actuality, as you can see, each block has, closer to 100, 150, 200 transactions sometime. And these blocks are getting proposed by various Ethereum miners. In fact, somewhere here you can see also fee recipient, this specific company, Beaverbuild, which is probably a company that has a bunch of Ethereum miners running all around the world, some cloud company most probably, or some mining company. Blocks, world state, and Ethereum as a state machine. So we are done with the recap of blockchains, and hopefully we remember, and if we did not remember, we understand that a blockchain is a bunch of thousands of millions of blocks that have been mined over time, and the last block looks like this. And based on this, I have some Ethereum in my account. You might have some Ethereum in your account. If you have ever freelanced, you might have asked someone, please send me Ethereum, I will accept Ethereum. Then in one of these blocks, your transaction is there where you received Ethereum as a freelancer. After that, your balance has been updated in the world state. So what are we learning next? We are learning about the world state and Ethereum as a state machine. This is what we're going to learn next. We understand blockchains. But what really happens in a blockchain is, blocks are getting executed, but then all of these machines are storing the state like this. What is this? It's just a key value pair, right? Harkirat's user account has 1.1 ETH, let's say. This specific user account has 2 ETH, so on and so forth. It is a key value pair. At the current point, the world state looks like this. The Ethereum world state looks like this. This person has this much Ethereum. In Ethereum, the world state refers to a mapping of all account addresses, ignore this statement for now, to their current states. It is a mapping of all account addresses to their current state. And for now, we will assume state is just kitna Ethereum pada wahan. The state is just how much Ethereum is present in that specific account. That is the world state of Ethereum. More technically, when the Genesis block was mined, when the very first block was mined, what does Genesis mean? Genesis ka matlab hota hai start. What does Genesis mean? It means the first block. So when this first block was mined, the world state was empty. No one had any Ethereum. Then the first block got mined. Some people received Ethereum as, the block reward. Some people might have invested in the IPO of or IDO of Ethereum. A lot of people became very rich by giving Vitalik some money initially. Ye lo $1 million, and they had already, reserved some Ethereum for them. And when Ethereum went to mainnet, they will also have some Ethereum over here. So as blocks ended up coming, the Ethereum world state became bigger and bigger. More and more addresses came into the picture. All of these addresses started to hold some Ethereum. After every block, this world state sort of changes. The world state initially was empty. After block 1, some accounts got some money, some more accounts got some money, some more accounts got some money. And this is, let's say, the current world state. The world state, for now we are assuming, looks something like this. Account 1 has this much Ethereum, account 2 has this much Ethereum. And can we say based on this, Ethereum is a state machine whose state changes as more and more blocks are added to the blockchain. It is a state machine. Ye rahi state. Isme ek block add ho gaya. Then this is state number 2. Then another block got added. This is state number 3. What is this called? This is called a state machine. You are going from one state to the next state based on some changes that happen in every block. So what is Ethereum? Ethereum is a decentralized, verifiable state machine. That is section number 2. We are done with what are blockchains. And Ethereum as a state machine, specifically the thing to understand was whatever these miners are running, whatever code these miners are running, is leading to a final world state that exists on all of these miner machines. All of these miners have this key value pair of this account has this much Ethereum, this account has this much Ethereum, by rolling through all the transactions since the beginning. 822. One more section we will cover. Then I will do a poll and understand if there are any questions. Let me look at Q&A if there are, just for like a second, any specific question. More. I don't see Q&A here. Well, you guys are out of luck. I don't see Q&A here for some. So one more section, we will do Q&A after that, all right? One more thing let's talk about. I have lied to you a little bit. I have said account has this much Ethereum, account has this much Ethereum. I said these are the only type of accounts that exist. Ethereum only does this. Ethereum only stores, this account has this much Ethereum. But haven't we learned until now? Okay, Ethereum introduced the concept of smart contracts. Solana had the concept of programs. Ethereum had the concept of smart contracts. So even though it might feel like this is the only type of account that exists, and that happens for Bitcoin. Bitcoin mein, you can only store native balances, transfer each other various balances. Doesn't do anything else. But the moat of Ethereum was, okay, anyone can come and deploy some code. Anyone can come and deploy a smart contract. So that is the thing that we're going to learn next. Okay, there are actually two types of accounts. An externally owned account. Externally owned account. An account that is owned by Harkirat. An account that is owned by Akash. These are externally owned accounts. Versus contract accounts. Can you already guess what a contract account would be? An account जहाँ पे आपका smart contract का code रहता है, right? When you ever create a smart contract on Ethereum and deploy it on the Ethereum blockchain, where will that contract be stored? That will be stored in a contract address or a contract account. If you ever create your own private key in Ethereum, then where will the private key, the public key of that exist? What is that specific account? That is an externally owned account. Let's dive into this a little bit deeper. What is an externally owned account? In Ethereum, an externally owned account is a type of account controlled by a user, for example, myself, through the use of a private key. Until now, we have seen, I haven't shared my slides, have I? Copy link. Anyone with link can view and copy. In Ethereum, an externally owned account is an account that is controlled by the user. For example, if you look at my MetaMask, this is one of my accounts. This is the address of this account. There is a private key associated with this account. This is the amount of Ethereum it holds. If I look at this address on Etherscan, which is, the link over here, Etherscan is very similar to SolScan in Solana that we saw, or explorer.solana.com. It lets you explore various accounts. The account that we are exploring has a public key, and we can see it has this much Ethereum in it. This is a externally owned account. Iski private key is stored somewhere here in this MetaMask. Very similar to how when we used Phantom, we were storing private keys inside this extension. This is a externally owned account. I'm assuming this is very straightforward to understand. We have just given it a more complicated term called externally owned account rather than calling it a Ethereum address. Just a technical term. What are the key characteristics of an externally owned account? What do you think? क्या होता है externally owned account में? अब तो some of you have Solana accounts, some of you are receiving bounties in those Solana accounts. So what are the characteristics of those public keys that you create yourself? They are controlled by private keys. Externally owned accounts are controlled by private keys that are held by individuals or entities. I hold my own private key. If I share it with you, then you can pretty much sweep all of my assets. So that is something you keep very close to yourself. If you possess the private key to an EOA or an externally owned account, you can initiate a transaction from that account, such as send Ethereum to someone else. Can I do that? If I go to MetaMask, do I have an option to send? Can I send some of this Ethereum over to someone? I just have to paste their public key, select an amount, click on send. I will be able to send them money. So what is the first thing an EOA lets you do? You can execute a transaction on behalf of that public key if you have its private key. What is a transaction? Sending 0.1 ETH to, let's say, Akash. No code or smart contracts. EOAs do not have any associated code or logic. Simple account hai bhai. Usme balance hai. That is it. Nothing else. It does not store any smart contract logic. It is not like Solana ke you can shove some data in there. Very simple. It will store your balance. This much balance this user has. Transaction initiation. EOAs are the only type of accounts that can initiate a transaction. How do I initiate a transaction? I go to my MetaMask, and from my EOA whose public key is this, I can initiate a transaction to send someone Solana or Ethereum, or I can initiate a transaction to swap Ethereum for, let's say, USDC. If today I need some USDC for some reason, I can just click on the swap button. I will initialize a transaction, which if it succeeds, my 1 Ethereum will convert to $2,400. Oh, oopsie daisy. Sorry about that. So that is another thing an EOA can do. Ether balance. EOAs can hold some balance of Ethereum. You saw I had 10 Ethereum or something in that account. And lastly, gas cost. EOAs must pay gas for any transaction they send. Whenever you are sending a transaction to the Ethereum blockchain or even in Solana, you pay some extra amount of Ethereum as gas. I told you a while back, you can also tip the miners a little bit. Here, ye rahi gas, and here is a small tip for you guys. Please execute my transaction first. So if you are ever doing any transaction on the Ethereum blockchain, be it transferring Ethereum to a friend or doing a very complex transaction like swapping USDC for Ethereum and then buying an NFT and then listing that NFT in a single transaction, then also you have to pay some gas. Now, of course, the amount of gas you have to pay if you are doing an extremely complex application is much more than in the amount of gas you have to pay if you are just giving your friend, 0.1 ETH. Cool. These are some properties of EOAs. I'm sure you already knew this because the same as a normal address in Solana, an EOA is in Ethereum. The world state we saw until now only shows the externally owned accounts, only shows EOAs. I have sort of hidden the other type of accounts for now. Let's look at what are the other kinds of accounts. Contract accounts. The name is pretty self-explanatory. In Ethereum, a contract account is an account that is controlled by a smart contract rather than by a private key. As in the case of externally owned accounts. In externally owned accounts, the private key holds that Ethereum. The private key can transfer that Ethereum. But in case of a smart contract or in case of a contract account, there is some code deployed in this contract account. इसमें कहीं एक code पड़ा होता है. Where is that code present? We will see very soon. But in a contract account, there is not just some Ethereum balance. It can hold some Ethereum balance also. A contract account can hold some Ethereum balance, but it can also hold code. In fact, it does hold some code, and that code governs कि ये Ethereum कहाँ जाएगा, कब जाएगा, किसको जाएगा. That code governs how will this Ethereum go away, how did this Ethereum come into this specific account, and how will it get transferred. If I show you the swap functionality over here, in this swap functionality, what am I doing? I am converting one Ethereum over to some USDC, 2400 USDC. So I am sending one Ethereum to a smart contract. It's not like there is a person on the other end जिसको मैं ये भेज रहा हूँ. I am sending this one Ethereum to a smart contract. That smart contract is dispensing some USDC to me. So smart contracts can actually hold Ethereum also. They can actually hold some code also. Both of these things can be present in a contract account, but in a externally owned account, only Ethereum is present. No data, no smart contract, no program is present. If you have already seen Solidity contracts in the past, heard of Solidity engineer or EVM engineer, then the code that those people write in Solidity gets converted into a format, and that code is also deployed over here. If you look at this specific address, you can click on it and open it up. You will see a section called contract over here. If I open this specific address on Etherscan, we saw one address a while back that was a externally owned account, only had Ethereum. This one has some code in it. You can actually see the exact code that is present. This code is not present on the blockchain. ये तो high level code है. This is the Solidity code that gets converted into some format. And this thing that you see over here, deployed bytecode, we will understand this very soon. Don't worry about it. But this deployed bytecode is what exists on chain. This is the data that actually exists on chain. This is the high level code of it. This is the Solidity code that gets converted into this bytecode, which is what is deployed on the Ethereum blockchain. So what are some properties of a contract account? They are controlled by code. We will understand this, in a while when we write Solidity contracts. But what it means is, they are not controlled by users directly. Instead, they are controlled by the code that was deployed when the smart contract was created. You might have heard, contract is the source of truth. Or, if I'm interacting with the Uniswap contract, how do I know if I sent it 0.1 Ethereum, it will send me back $2,400? Because it's written in the code. I can read through the code and actually see that it has logic over there. If it receives X amount of Ethereum, it finds out the current price of USDC and gives me back some USDC from it. So I can actually read through the contract. The contract is the law. The code is the law. वो अकाउंट में जो इथीरियम पड़ा है, जो USDC पड़ा है, that can only be dispensed by the contract. But of course, it can't do it automatically. The contract account can't initiate a transaction. Transaction initiate तो मुझे ही करनी पड़ेगी. I have to initiate the transaction to call a function on a smart contract. When I call that function, then that function ka code will run and might send me back some USDC for the Ethereum that I sent it. So contract accounts can hold some code. They cannot initiate transactions. वो खुद से नहीं भेज देगा मुझे. I have to initiate a transaction. I have to send it some Ethereum. Then it will send me back some USDC. Contains smart contract code. We will be writing a bunch of this code very soon. We will write a lot of anchor contracts for Solana. We will write a bunch of Solidity contracts for Ethereum. So that code eventually gets stored on the chain. Of course, not in your high level code, not Solidity syntax, but some conversion of that format into some bytecode is what gets stored on that smart contract account. It can also store Ethereum balance. So one, mildly counterintuitive thing that you might see now is that when you interact with Uber, you don't send money to Uber ka backend. You send money to Uber ka bank account. You transact money gets debited from your SBI account, goes into Uber's HDFC bank account whenever you are paying. From there, from Uber's HDFC bank account, it goes to the driver that is driving. But in case of Ethereum and Solana, in case of blockchains, these accounts can actually hold some Ethereum also. इसमें code भी पड़ा है, इसमें Ethereum भी पड़ा है. And the code governs कि Ethereum कब जाएगा, कहाँ जाएगा. The code governs when will the Ethereum go, where will the Ethereum go, which account can claim how much Ethereum from it. So it has a Ether balance as well. Gas cost. Contract accounts require gas. Whenever you're calling a function on a smart contract, you have to pay some gas. But the gas fees is paid by the EOA that initializes the transaction. If I go over here and try to swap some Ethereum for USDC, even though I'm calling a smart contract function, even though I'm calling that contract address to do something, I will be the one paying the gas for it. The smart contract won't. I will pay the gas for it, while that, for that transaction to execute. And lastly, permanent deployment. In case of Solana, was this the case? In case of Solana, when you deploy a program, can you change it? Yes. In case of Ethereum, when you deploy a contract, can you change it? No. There are nuances to both of these statements. In Solana, you can make the contract immutable. You can make the contract, you have to explicitly make the contract immutable, which means it cannot be changed. In case of Ethereum, it is by default immutable. You cannot change it. But there is a concept of upgradability that we will talk about eventually that sort of lets you, update contracts as well. It's a very nice concept. If you understand it from first principles or try to write it from first principles, you'll sort of, learn a lot and understand a bit about how does upgradability work there. So this is what the world state actually looks like. Abhi tak to I was lying a little bit that world state looks like something. This is what the world state actually looks like. An address holds some Ethereum, and there is some extra thing that I'm showing. We'll talk about what this is, the nonce. And then another address, which is a contract address, which stores the nonce and the balance. जो चीज़ें यहाँ हैं, वो चीज़ें यहाँ भी हैं. But it stores two more things, the storage hash and the code hash. Two extra things it stores. High level, hopefully you can understand कि अच्छा, since this is the smart contract account, this probably stores the actual code, the byte code that the Harkirat was showing. And this storage hash probably represents some way to reach the storage. Storage क्या है? मतलब if you are creating an Uber smart contract, then what are the rides that have happened in the past? What is the currently running ride? This state, which if you remember in Solana we were storing in accounts, in case of Ethereum is stored somewhere in some very complicated tree. In the world state, it looks like this. Okay, it has a storage hash and a code hash. We'll get to how you can compute the storage hash and the code hash. And along with that, it has a balance and a nonce. Same for this guy. What is this nonce? We will get to. This is not the same nonce as Bitcoin. This is something else. This nonce and this nonce are very different. Balance is the only thing you might understand from first principles. This has a balance, this has a balance that is stored in the world state of Ethereum, that is stored in the every miner that exists. Baki sab kuch extra hai. Storage hash, code hash, and nonce for a contract address. And for an EOA, just the nonce is the other extra thing that is stored. Can we do a quick poll? Let's see how many of us थोड़ा understand कि अच्छा Ethereum has a world state. It has two types of accounts. Normal accounts can only store a balance and some other field here. Contract address can store a balance, some other field here. And two more things, a storage hash and a code hash. Let's do a quick poll. %, that's pretty decent. Pretty decent for the fact that we just started right now. I think I can proceed if it's 85%. Let me look at the Q&A for just like a minute and then I'll think. Contract account is similar to PDA in blockchains. No. Contract account is not similar to PDAs in Solana blockchain. PDAs in Solana blockchain actually store the state. It's very different. In case of Ethereum, you have a single address that sort of stores the whole state. In case of Solana, you have multiple addresses that store the state of your application. If you are creating an Uber application, in Solana, you will have thousands of accounts because each account, which as you mentioned are PDAs, will be storing, this is user one's details, 2 bytes that are stored here. This is user 2 details, 2 bytes that are stored here, so on and so forth. But in case of Ethereum, there is a single account. When you deploy the smart contract, single account from which you can reach the actual storage of your specific contract. यहाँ पे stored है कि user 1's name is this and user 2's name is this and user 3 name is this. So this guy, this one account, if you create on Solana, you have to create thousands of accounts if you are creating the same application. If you are creating an Uber application, very simple on Ethereum, very difficult on Solana because Solana may you store all the data across thousands of addresses, which are called, which are not called PDAs, but usually they are PDAs. Where does the gas fee go to? Some of it goes to the miners, some of it gets burned. That is how Solana and Ethereum have value, right? Why does Solana and Ethereum have value? You might have heard of the term inflationary and deflationary. The goal is that Ethereum, all blockchains become so important. Everyone is transacting on them. Everyone is paying a lot of gas fees. Some part of this gas gets burnt. Burnt मतलब किसी के पास नहीं गई. It did not go to the miner. It did not remain with you. It got burnt. हवा में चली गई. If that keeps on happening, then the supply of Ethereum will keep on going down. If the supply of Ethereum goes down, then the price of Ethereum will go up because there will be less and less Ethereum to buy. So that is why people say Ethereum became inflationary. Ethereum became deflationary. If it is inflationary, मतलब जितना अभी mine हो रहा है, the amount of Ethereum that is getting mined is more than the Ethereum that is getting burnt. But if there is a lot of transactions that is happening, then Ethereum becomes deflationary also. Then more Ethereum is getting burnt, less Ethereum is getting created. What does it mean that smart contracts only responds to the transaction? This is a smart contract. No, this is my personal address. This is a smart contract address. As you can see, it has a contract section here. It can't initiate a transaction. It doesn't have a MetaMask through which it clicks on a send button and sends a transaction. It's a very bad example. But in my MetaMask, I initiate a transaction, right? I say I want to send someone Ethereum. I am the one who's paying for gas. I am the one who's initiating the transaction. Contract can't initiate a transaction. If no people initiate a transaction on the Uber smart contract, वो पड़ा रहेगा वहाँ. It will stay there. It cannot initiate transactions itself. के yellow reward, I want to give you something. No. Contract once deployed can't initiate transactions on its own. People can initiate a smart contract call. People can call a function over there. So that is what it means. Okay, people can initiate transactions, and smart contract cannot do it itself. Do smart contracts have owners and authority like Solana? So no, there is no concept of authorities in smart contracts. You can't even upgrade them, so it doesn't make sense to have an authority. You can probably see who deployed it, but there's no concept. And in your smart contract code, you can write some logic. Okay, the admin can do this, the admin can do that. The person who created the contract can do some things, but there's no concept of an authority. You can't ever upgrade a contract or do anything with it. Can smart contracts send Ethereum they hold to someone else? Because that will be, so exactly. They can send it, but I need to initiate that transaction. If I am a hacker and I created a weird contract where everyone's putting Ethereum, I will have to initiate a transaction to pull all of that Ethereum. I will have to initiate it. Of course, it can send all the Ethereum to me. I can pull the Ethereum from there. Cool. Okay, that's some set of questions. I'll answer more questions towards the end of the class. I don't think we'll be able to finish the whole thing today, but let's see how far we can go. ठीक है जी. This is the world state, and इसमें one of the questions that was asked to me in the interview was, how does Ethereum store balances? If you have 0.2 Ethereum, where do you think that is stored? So the answer is, it is stored in the world state. More specifically, it is a mapping from my address to the balance that I have. As simple as that. It is very different in Bitcoin. Bitcoin has, this concept of UTXOs, if you might have heard of them, unspent transaction output. So it's very hard to calculate how much Bitcoin someone has. You have to sort of keep going back the chain. That was my first answer in the interview. And he said, that's how Bitcoin works. And I was like, yes, that's how Bitcoin works. Ethereum, the mapping is simply stored in the world state from the address to the balance. That's the simple thing. But Ethereum lets you create programs also, contracts also. It needs to hold the program code somewhere. It needs to hold the final data somewhere. We will write some Solidity contracts very soon. So you will see how our program gets some data. You can have a hash map over there, which has the mapping of, let's say, how much rides a person has done if it's an Uber contract. So it needs to store some data also. It needs to store the original code also. If you remember from the Solana classes, we said this code that you see over here is deployed in one program. And it is similar to your Node.js code that runs on an EC2 machine. If you today create a full stack application, your code is what you deploy on EC2 machine. Your storage is your database. If you are storing your data in a MongoDB database, in a Postgres database, that data is equivalent to the storage over here. And your Node.js code is what's equivalent to the code over here. So let's kick things off by understanding these complicated fields. Balance, hopefully we understand. Nonce is the first one. Nonce is such an overused term. It came in Bitcoin as well, is coming in Ethereum as well. What is a nonce? In case of an externally owned account, a nonce is the number of transactions sent by the EOA. It is the number of transactions that I have sent. If I send a transaction to send someone Ethereum, my nonce goes up by 1. If I swap some Ethereum for Solana or USDC, my nonce goes up by 1. Every transaction that I initiate, my nonce keeps on going up by 1. That is what the nonce field over here represents. What is its purpose? It ensures unique transaction ordering. You might remember a little bit in Solana, there was this concept of a recent block hash. If you don't, that is fine also. But what did the recent block hash do over there? It ensured that if the transaction isn't picked for a while, तो वो dump हो जाती है. That transaction isn't picked. The recent block hash is not the same as the block hash in the last 10 blocks, let's say. If you did not understand this part, it's fine. But in case of Ethereum, if you remember I said, you are sending a lot of transactions that might get picked after 3 days, that might get picked after 5 days. So this nonce ensures कि अगर आपने एक transaction भेजी है, and you're trying to, let's say, send the same transaction again, so the second transaction will get rejected. If you send the first transaction, usme nonce was 5, send the second transaction with the same nonce, whichever one gets picked first will be executed. The second one may nonce will become invalid. So it makes sure you uniquely, every transaction of yours is ordered, and it's the number is going up by 1 and going up by 0 and going to whatever, as many transactions as you have done. Increases after every transaction. Every time you do a transaction, this number increases, and it is used for preventing double spending, making sure if you try to send the same transaction again, you're not able to do it. Your second transaction gets stopped. You might assume the same thing happens here. That was my assumption, if I'm being honest. But then I read that is not the case. Nonce in address accounts do something different. I thought every time there's a transaction that happens, every time there's a function call that happens, the nonce would probably go up. But the nonce does a slightly different thing in case of a contract. Here, the nonce is the number of contracts created by the contract. A contract can actually create other contracts, and the nonce over here represents how many contracts this specific smart contract has created. One program can create another program. The number of programs that you have created is represented by the nonce field over here. Balance, we understand, it's the same thing. The number of Ethereum in this specific account. Purpose is this increases after contract creation. Every time you create another contract from this contract, the number of this nonce number over here increases, and the purpose is to determine the address of the newly created contracts. As you create more and more contracts, you can actually deterministically find their address based on this nonce. 0th nonce pe this contract was created, 1 nonce pe this contract was created, so on and so forth. That is the purpose / need of this nonce field. Do you use it usually? No. What do you usually care about? Here you care about the balance. Here you care about the balance. Storage and code. Okay, where is this data of my smart contract held? Where is the code of my smart contract held? So let's balance. We already know, hopefully it's simple enough, how much ETH I have, how much ETH is in the contract. How does Ethereum reach a contract? People initiate transactions, right? For example, if I initiate a transaction here, okay, I want to convert one Ethereum to some USDC. I will send one Ethereum over to the program. And then if the program hopefully does the right things, it will return me back some USDC also. But this is how you can send Ethereum to a specific contract. You might have remembered, if you've gone through Solidity, you might have heard of the payable field there. That lets you send Ethereum to a smart contract. The amount of Ethereum that is present there is represented by this balance field. The other two things over here that are present are sort of, the new things in a contract account that don't exist in a EOA. The storage hash, which represents, it's a hash, so it's not the actual storage. अगर आपकी एप्लीकेशन में कल को हजारों यूजर्स हैं, if you have thousands of users in your Uber smart contract, their data is stored somewhere else in a very weird, very long tree to make it highly optimal. This is just a hash of that state. Hash का मतलब क्या है? Do you remember hashing from initially SHA 256, various hashing algorithms? Hashing is one way, encryption is two way. So this is a hash of the current state. Each smart contract in Ethereum can store data in its own storage. That is this, which is a key value store. This is the actual storage. The storage contains things like the variables defined in the contract. Who has done a ride in your Uber contract? How many rides have they taken? Where was the first ride initiated from? All of that data is stored over here. The storage hash is the root hash of the contract storage tree, which is it is just a cryptographic representation. आपका पूरा tree ले लो and pass it through a hashing function. Whatever gets spit out is the storage hash. If the state changes a little bit, if some new ride happens, then of course a new hash will be generated that will be different. Every time the state changes, the hash changes. And the hash is sort of, it lets you check. Why would you have a hash like this? So that you know कि अच्छा इस state के लिए ये hash आया था. And you can check the purity of the state. अगर किसी और के पास भी वो state है, someone else has the same state, they can pass it through the same hashing function. If they get the same hash, means the state is correct. So it is a smaller representation of the current very big state that exists on Ethereum. So that is what the storage hash is. And can you guess what the code hash is then? कि आपने जो code deploy किया है, the code that you have deployed, if you pass it through a hashing function, it spits out the code hash. Smart contracts in Ethereum are written in high-level languages like Solidity, but are compiled down to EVM bytecode. We will understand this very soon. What is this EVM bytecode? If you might remember, a while back I showed you some bytecode in a contract for execution on the Ethereum virtual machine. We will understand what the Ethereum virtual machine also is. The code hash is the cryptographic hash of the contract's bytecode. जो bytecode user ने डाला, whatever Solidity code user wrote got converted into a bytecode. If you pass that bytecode through a hash function, that is what is stored over here. The code is stored separately. This is a hash of that code. And do you think this hash can be changed? No, right? Because these contracts you can't really upgrade an Ethereum smart contract. You can't really, it's immutable. You can't change, upgradability is a concept, but you still can't change the original contract. It happens in a very weird way that you upgrade contracts in Solana, in Ethereum. So once the smart contract is deployed, its code hash is permanently fixed unless the contract is destroyed. So this code hash doesn't change. The storage hash changes a lot as your storage changes as well. That is a brief of the Ethereum world state. What were we supposed to cover today? If I go back to the original slides, we were supposed to cover recapping what is the blockchain, blocks, world state and Ethereum as a state machine, and types of accounts. These are the three things we have covered. Slightly overwhelming, slightly this is happening for the first time. Some of it needed, some of it not needed in your Ethereum journey. The next part is slightly simpler. This and this should be easy to digest. The next three parts, if I'm being honest, because they're more Web 2 concepts. Ethereum also uses this sort of a Web 2 concept to create the Ethereum virtual machine. But VM, JVM, physical machines, virtual machines are sort of a Web 2 concept. DevOps people here might be very comfortable with it already. So let's quickly hash out these three and then we'll get to the actual difficult bits. Hopefully today. What time is it? 8:52. Do you guys want a break? Yes or no? We can either finish this by 9:30 or we can do a break Q&A right now and finish the rest of the things later. So do you want a break, yes or no? No. Great. That is what I was hoping for as well. Love it. So no break, 60, pretty close, but 60% said no. So let's continue. Let's get into the slightly Web 2 concept. Let's understand with virtual machines and physical machines. Some of you already know them because some of you have tried to, create a Ubuntu machine inside your Windows machine. I don't know if you guys have tried it. Some people might have tried a Windows machine inside an Ubuntu machine. Do you think you have the hardware for a Windows machine? No, right? Or do you have the hardware for a Linux machine? Sort of. But the machine that you are creating is not a real machine. The operating system is it is running on top of some virtual layer. That is why it is called a virtual machine. What is a physical machine? Let's start there. Mac machine that you might have, Windows machine that you might have. A physical machine refers to the actual hardware such as servers, desktops, laptops, where computing tasks are defined. This machine that I'm currently working on, the machine that you are on, is a physical machine. It comes in with the OS operating system. You might have a Windows operating system, Mac OS operating system, Linux operating system. Normal machines that we are usually comfortable with are physical machines. Nothing too complicated here. Hopefully this is straightforward. A virtual machine is something new. A virtual machine is an emulation of a physical machine. Emulation का मतलब क्या होता है? What is emulation? कि you are emulating, मतलब simulating, मतलब recreating that specific virtual machine on top of your physical machine. It is an emulation of a physical machine. It tries to emulate a physical machine. वैसा सा दिखता है. Looks very similar, but it isn't a physical machine. If I start Windows on my Mac machine right now, somehow I don't have Windows hardware. I don't have a Windows machine. I have created a Windows virtual machine. It allows you to run multiple operating systems on a single physical machine by abstracting the underlying hardware resources. I have hardware that usually should run a Mac OS machine, but I can start a virtual Windows machine over here, a virtual Ubuntu machine on my Mac. This abstraction is done using a hypervisor. Do we know this term? Do we know data centers have this concept of hypervisors? Have you ever gotten your own hypervisor and created your own server? A hypervisor or a virtualization layer. What is it? A virtualization layer. A software that can let you, sometimes software, sometimes hardware also, that lets you create virtual machines. So how are virtual machines created? They are created using a hypervisor, which allocates resources, CPU, memory, things like these to every virtual machine. So you can either have real physical CPU on your machine and run a physical OS, or you can run a virtual machine in there that has virtual access to your CPU, some little bit access to your CPU. The softwares or hardwares that let you do it are called hypervisors. So if this is my physical infrastructure, what do I mean when I say physical infrastructure? My Mac machine is my physical infrastructure. I can install a software on top of it called a hypervisor, which will let me run, let's say, an Ubuntu machine. So if this physical infrastructure is my Mac machine, then I can run a virtual hypervisor, a software that lets me run an Ubuntu machine, start the real GUI of an Ubuntu machine. This physical infrastructure could also be data centers. When you go and start an EC2 machine, doesn't it say vCPUs, virtual CPUs that you have access to? What do you create? I want to create a new virtual machine. Whenever you go through a DevOps course, what do they say? Let's start a virtual machine on AWS. Let's start a virtual machine on DigitalOcean. So for them, this physical infrastructure is a swarm of CPUs, RAMs, lot of storage. They have a lot of this in there, and they have physical hypervisors, like a device also, on top of which they create EC2 machines. So this is how you can create an Ubuntu, just like a screenshot that I got, Ubuntu running inside a Windows machine. But in case of AWS uses a hypervisor to abstract the physical hardware and allow multiple EC2 instances to start and share the underlying infrastructure, the underlying resources. Each EC2 instance operates independently, just like a virtual machine with its own operating system, storage, networking. When you are starting a machine in AWS, you are not getting access to a single machine that is present over here. कि ये लो ये आपकी है. You can do a lot of shady things there. You can destroy their whatever, software, hardware, do 10 different things. They give you a virtual machine. If you destroy this, reboot this, do whatever with this, the underlying machine doesn't reboot. ऐसा नहीं है कि you took down their servers if you shut down an EC2 machine. The virtual machine stopped. The virtual machine will restart. Each EC2 instance operates independently, like a virtual machine with its own operating system, storage and networking. देख के नहीं समझ आएगा. You can't look at it, assess into it and tell कि oh, this is a virtual machine. But in actuality, it is just a virtual layer on top of physical infrastructure. You have some restricted access to this physical infrastructure. That is why when you check the CPU limits on a machine, it says you will get access to 8 vCPUs, virtual CPUs, 16 vCPUs. The hypervisor sits between the EC2 instances and the physical infrastructure, managing resources, security, etc. So this is how a virtual machine works. Great experiment for you to run might be to start a virtual machine on your whatever Windows machine after the class. Try to start Ubuntu, let's say. We understand virtual machines. Thoda, they do something. Let's understand the Java virtual machine. Harkirat, why are we learning Java? This isn't a Java course. Yes. But some concepts that we learn here can be very well applied to the Ethereum virtual machine. Java people said it first. They first created a virtual machine for a language. They created the Java virtual machine, and very similar concepts were sort of used and inspired the Ethereum virtual machine. I don't know if Java virtual machine inspired the Ethereum virtual machine, but they pretty much do something very similar. The Java virtual machine, and if you're a Java person, you tell me, I know this from the very top, from my JVM days or whatever, Java days, was introduced as a core part of Java's write once, run anywhere philosophy. Write once, run anywhere. The problem with languages like C, C++ is, if you compile them on a Windows machine or a Mac machine or a Linux machine, you can't run that binary other places. It's very hard to create a binary for a language like C++ in one operating system and move it to another operating system. You have to move the high level code there and recompile it for the architecture of that machine. You might have seen this problem from time to time. Okay, you compiled a binary, you converted your C++ code into a binary on your Mac machine, you move it to a different machine, it's not working there. The compilation step sort of changes for every architecture of machine that you're running it on. So the Java people said, okay, we are going to introduce a philosophy, write once and run anywhere. You write your Java code once, you convert it into some binary, some what's more technically called bytecode, and then that bytecode, don't run it directly on your Mac machine, don't run it directly on your Windows machine. That bytecode will run on the Java virtual machine. So if you want to run Java code locally, if you've ever started Java locally, you might remember you have to start JVM, Java Virtual Machine. The main reason for JVM was to solve the portability issues and make Java run consistently across various platforms without needing to be recompiled for every operating system. If you have a C++ program, if you've ever run G++ file name -o output.bin, and you've tried to move it to various different operating systems, it will not work there. It is not compiled for that architecture. But Java, you compile it once, it runs everywhere. Why? Because it's not directly running on the machine, it is running on the JVM. It is running on a virtual machine that you start on your physical machine. So if you have a Windows machine, Ubuntu machine, Linux machine, doesn't matter. If you want to run Java code there, first you start the Java virtual machine. Then you take your original Java code, compile it into bytecode, and this bytecode runs on this JVM. It does not directly run in your Windows machine. It does not have operations that are written that your core operating system can understand. It has operations that are written that your JVM can understand, and JVM to har jagah same hi hai. When you start a JVM, doesn't matter where you start, the same thing only starts, which is why if this Java code is compiled on any operating system, doesn't matter. Since it is not directly running here, it is running here. It sort of, just runs everywhere. You write once, compile once, run everywhere. The same bytecode can run on every operating system as long as the operating system has JVM. This operating system is running another virtual machine. Now, not a very big virtual machine. We don't want a GUI. We don't want to start Windows on my Ubuntu machine. We want to start something else. A Java virtual machine doesn't have a display, doesn't need anything complicated. Very small virtual machine that is interpreting this bytecode. This bytecode isn't going to the Windows machine directly. Cool. That is what the Java virtual machine is. Let's do a small poll. Do we understand JVM? How is it different from VM? What was the philosophy that these guys used to create the JVM? Very good. Java people love. 93% understood this. Are you all Java folks? My condolences. If you understand JVM, EVM is very similar. Ethereum virtual machine. Ethereum virtual machine is conceptually similar to JVM in that both are virtual machines designed to run platform independent code. But the difference in their purpose, design, and what they execute, they differ in some parts. But one big reason to create an Ethereum virtual machine was that just like Java, one bytecode is deployed, it runs on every operating system. अब ऐसा नहीं है कि a Windows person that is trying to start an Ethereum node needs to compile the Solidity code a different way. बहुत complicated हो जाएगा. There are thousands of contracts. What will you do? Compile every contract into various binaries? No, right? कल को नया operating system आ गया तो if there's a new operating system that is introduced, will every smart contract developer redeploy the binary there? No. So that is why Ethereum folks created their own virtual machine. They said, यार बहुत बढ़िया, very nice concept. We will also create an Ethereum virtual machine. Now write Solidity smart contracts, create Solidity smart contracts, convert them into a bytecode. I will be able to understand and interpret and run this bytecode. So EVM, very similar to JVM, expects you to write Solidity code, convert the Solidity code into bytecode, and that bytecode it can execute very quickly. Now in case of Java, you run this bytecode when you in your local machine, you start the whatever Java process, you run Java main, run the whatever processes to start the Java process. That is when this bytecode executes. In case of Ethereum, when do you think ये bytecode पहुंच तो गया Ethereum पे? When I deployed the smart contract, this bytecode reached somewhere. When does it get executed? Whenever you initiate a transaction. Whenever I initiate a transaction, some part of this bytecode gets executed over here based on what function I am running. This Solidity contract might be for a very big decentralized exchange. Lets you swap a lot of things. Gets converted into a bytecode. When I am over here and when I am swapping one Ethereum for something, clicking on send, some part of this bytecode is what gets executed on this EVM everywhere. On all the miners that are there, they will all run my, swap function, and they will all decrease my Ethereum balance. They will all increase my US dollar balance. So EVM, very similar to JVM, is the real Ethereum virtual machine. This is where, this is the thing that Vitalik created. This is the place where a lot of research happens. If you can make this code faster, then you can make thousands of Ethereum nodes very fast, help them process more transactions, things like these, which is why there are various clients of Ethereum. There are various Ethereum clients. What do I mean when I say Ethereum clients? Any code that lets you start this virtual machine. Any code that lets you start this virtual machine is what is called an Ethereum client. This is one, CPP Ethereum, Go Ethereum. There are many popular implementations of the Ethereum client. क्या फायदा है इसका? What is the benefit of this? Amongst many benefits, one very big benefit of this is decentralization. I said this initially. Okay, one very big benefit of this is, okay, this slide sort of covers the same thing. One very big benefit of this, okay, Ethereum has multiple clients, is that some people are running the Ethereum Go client. Some people are running this Ethereum CPP client. Someone else is running some other code. All of them are starting this virtual machine only. All of these codes, all of these clients do the same thing. Code similarly likha gaya, but one is in one language, the other is in another language. Why does this help in decentralization? What if one of this miner gets hacked? What if one of this clients gets hacked? Someone pushes in a buggy code here. So some of the nodes will go down. Let's say these 5 nodes were running this program. These 3 nodes were running this program. So why does it help in decentralization? So that if there are 10 different clients, everyone is using different clients, then if one of the clients has a hack, ये बहुत क्वेश्चन आता है कि what if Ethereum वालों ने कोड चेंज कर दिया तो what if the Vitalik only changed the code? Number one, none of these miners will accept that code. They will keep running the old Ethereum client. इसके भी तो versions बनते हैं ना. Just like you add updates to your website, your full stack application, this also updates over time. The miners can choose to not upgrade their code. They can choose to not pick the latest code from here. If they do pick the latest code and there was a bug here, only some machines are affected. Other machines are still running the Go client. यहाँ पे इन्होंने virtual machine Go से start कर दी. Of course, there will be desyncing issues. There will be a lot of things. These guys will start to propose some random transactions, accept some random transactions, but that will be limited to a few machines, because only some machines use this client. Only some machines use this client. This was one of the downsides of Solana. Solana only had one client. Now you might have heard of Fire Dancer, which is another client, similar to how Ethereum has two clients. Now Solana is also getting a new client called Fire Dancer, which is written in C, supposed to be really fast, things like these. So every blockchain mein, how do you know कि Vitalik, how do you know it's truly decentralized? If भाई कोड भी बहुत लोग लिख रहे हैं, मल्टीपल पीपल आर राइटिंग मल्टीपल इंप्लीमेंटेशन, तो एक सिंगल बंदा कोड भी नहीं चेंज कर सकता. A single person can't even hack the Ethereum protocol because someone else has written the protocol in a different language. ये थोड़ी हैक हो जाएगी, एक साथ सारे थोड़ी हैक हो जाएंगे. Not all implementations will get hacked together, which is why even Vitalik, if he wants, he will make a change here. But these clients that are written by some private entity will be like, we will not accept this code. This code is buggy. So that is why there are various implementations of EVMs, and it's a good thing. Everyone, miner can choose which one to pick. Some of them are faster, so they would prefer the faster one, so on and so forth. This is a checkpoint, folks. If you understand this, then we'll get into slightly harder concepts now. Solidity, ABIs, bytecode, and opcode. Let's do a quick poll. Are we good to go, guys? Can we get into Solidity, which I'm assuming some of you already know? ABIs, bytecode, and opcode, we good to go? All right. 83%. Okay. Why was there a 2% drop? Very quick Q&A I will do for a few seconds or maybe a minute. Then we will go back here and understand these four concepts. How is code written in multiple languages talk to each other? Can I not write code in Node.js and have another microservice in Golang and make them talk to each other? I can, right? I can send an HTTP request here. I can create a WebSocket connection to this. I can do a WebRTC connection between two machines where different languages ka code is written. So as long as the protocol is defined, कि यार Ethereum uses this communication protocol, this guy also implements it, this guy also implements it, they can talk to each other. Sorry, let me go down. How much will I earn if I run Fire Dancer? Well, you will earn pretty similar to how much you would earn if you run the original implementation. It doesn't matter which client you are using. वो तुम्हारी stake पे depend करता है. How much Ethereum you have staked derives how many times you will, be able to become the block leader. So the client doesn't really matter there, but you'll be processing it much faster. You'll make the overall blockchain much faster. But it's not like you will get more rewards if you're running a different client. All right, some good over here. How will node affected by buggy client change if the state to the correct one? Or they will restart another client. They will sync the state again from the correct clients, just like a new person would, right? If I'm a new Ethereum miner, I will have to sync state. So just how I will sync state. All the buggy ones will be like, हमारा तो हालत खराब हो गई. They will, they can revert the code and slowly catch up to the blockchain. They have the old good blocks. They can get the new good blocks, or they can resync state from the top. Why is it called state machine? Why can't we call it a database? A database is not a state machine. That is why. A database is not a state machine. Beautiful question. If this is a database, I mean, I don't know if it can be called a state machine also, but basically ऐसा होता है कि इसमें person 1 has 1 rupee, person 2 has 2 rupees. You sort of override these values from time to time. इसकी value 5 हो गई. You can't recreate the state. You never store an audit log, right? आप ऐसा नहीं स्टोर करते हो कि सबसे पहले person 1 sent person 2 5 rupees and then person 2 sent person 3 3 rupees. You don't store this list of states. If you store them, sure, a database is also a state machine. But this comes from if you've heard of a Turing complete machine, if you've heard of the original computer, things like this, वहाँ से this term comes, it is a state machine. All right, we will proceed. Happy to take doubts at the end. Let's complete at least these 4 concepts. So we are done with, we're done until this point. Architecture of EVM may become an offline video. We will see. But let's first cover this. I think this should be doable today. Let's see. Let's understand 4 more concepts. And if you did not understand some things until this point, 1, they're not super important, but 2, I will answer a few doubts at the end of the class. Let's try to finish as much as we can till 9:30. So 85% can move on. 15% के answers I will take later. Great G, beautiful. Let's understand the real sort of concepts that are good to know. इससे पहले की चीज़ें, everything I've discussed before, will help you in an interview for like a blockchain or a L2, or generally good to know. Bhai. Good things you learned only, nothing bad you learned. The next set of things that we're learning, Solidity, ABIs, bytecode and opcode, is something you will be dealing with on a day-to-day basis. Opcodes maybe not, but Solidity, ABIs and bytecode, even as a smart contract engineer, you will be spending a lot of your time there. So these are super important to know. Solidity being the most important, ABIs probably being the second most important, then bytecode, and then opcodes agar nahi bhi aate, that is fine. Let's kick things off with Solidity. Hopefully if you've gotten this Web3 course, you have at least heard of Solidity. Solidity is a high level programming language. Java is a high level programming language. C++ is a high level programming language. Languages that you and I as humans can write. We all know that machines don't understand high level languages. They don't understand where a equal to 1. They don't understand int main. They understand zeros and ones. And in case of EVM, they understand something else called opcodes. But they don't understand int a equal to 1. That is the concept of high level programming for us normies. The computer understands zeros and ones. Solidity is a new language that these guys created, Ethereum folks created, designed for writing smart contracts that run on the Ethereum virtual machine. So whatever code you write here doesn't directly run here. It of course gets converted into a format which runs on the Ethereum virtual machine. Developers use Solidity to implement smart contracts that can be deployed on the blockchains such as Ethereum or even Solana, but like Ethereum, or no, Solidity only for Ethereum or EVM chains, allowing for the creation of decentralized applications or dApps. So step one is, why do you create smart contracts? Sarkiyat, why should I learn Solidity? Because whenever I am swapping over here, I am calling a function in a smart contract that is written in Solidity. All the money that is made in blockchain, most of it is made by running some smart contract. If you are, I mean, not all the money, but like a lot of it, decentralized exchanges, whatever is, taking my 1 Ethereum, converting it into $2,400 and taking $20 in the middle is a smart contract. It is written in Solidity, which is why to create a decentralized application, this is a decentralized application. It is an application, but it takes my Ethereum from my private key. No government can come and block it. Converts it into USDC directly in my Ethereum account. That is why it's a decentralized application. Any application that can interact with my MetaMask is called a decentralized application that can request to debit money from there, request to put money in there, or request to do things on my MetaMask account is called a dApp. This is a good example of a dApp. To create a dApp, you need to use the language. You can also write it in other languages, but Solidity is the most popular one. Developers use Solidity to implement smart contracts that can be deployed on the blockchain such as Ethereum. Here is a simple smart contract. We will learn the syntax of Solidity very well eventually. I have a video on it, but that video is completely bonged on YouTube. Uska audio video has desynced for some reason, so you will not be able to go through it. But high level, can we understand this code? Thoda. Okay, here is a smart contract called simple storage that lets me declare a variable called stored data, lets me update that variable, lets me fetch that variable. It defines two functions, one to update the data, one to get the data. Now the syntax is not very weird. If I'm being honest, it's simple syntax, right? A contract, define the variables, function number 1, function number 2, set function takes a number as an input, uint 256, a 256-bit unsigned integer as input, sets it to this variable. If you want to get the value on that specific variable, on that specific storage, you can call the get function. I had a very nice comparison between this and JavaScript. There we go. If this feels a little hard, can you compare it to a class in JavaScript? I have created a class in JavaScript called simple storage. It has a constructor. There's no constructor here, but you can also add a constructor over here. If I wanted to give it a default value, I can also add a constructor in this contract. A constructor is something that gets called when you initialize an object here, when you deploy this contract. Agar ye contract deploy hoga, a constructor over here is called, which, let's say, as the name suggests, constructs the contract, constructs the object of this class. For the people who don't know JavaScript, similar to classes in Java, right, or any other language, This is the class, this is the name, this is the constructor where I initialize store data to 0. Here I did not need the constructor because it will by default be 0. Then a set variable that lets me update this stored data variable. Same thing is happening here. A get variable that lets me fetch that data from there. Fetch the stored data variable. That's why it's called simple storage. It lets you store a number on the blockchain. That is what this Solidity contract lets you do. Hopefully this is high level clear. We will dive into the syntax of Solidity, but high level, this is a smart contract. It's a fairly useless smart contract. It lets you store some data on the blockchain, specifically a number. You can set the number, get the number. Anyone can set the number, anyone can get the number. This is the high level code that you write. A bunch of this code we will be writing as weeks go by. Question is, what happens when you compile the Solidity code? What format does it get converted into? Bytecode is the low level code that is generated after a smart contract written in a high level language like Solidity is compiled. When you take this high level code and call the Solidity compiler on it, it will generate two things for you. We will come to the second thing. But the first thing it generates is this byte code. Bunch of code in bytes. That is what byte code is. A bunch of code in the form of zeros and ones. So you convert your high level code into byte code. It is a sequence of instructions that can be understood and executed by the virtual machine. So these zeros and ones जो होते हैं ना, these zeros and ones, you can actually read them. They're actually what are called instructions, or more specifically opcodes. ये भी हम पढ़ेंगे. We will learn about opcodes also. But you can actually interpret these zeros and ones. If you are curious, if you want to ever decompile binaries, have you heard of decompiling binaries? Have you heard of reverse engineering binaries? What do you do there? You literally go into the zeros and ones and try to understand what is happening. If you've ever done a compiler design course in class or in school, there you understand how does this high level code get converted into a low level zeros and ones? How does a for loop over here look like in zeros and ones? How does an if else over here look like in zeros and ones? So Solidity code gets converted into byte code, and this byte code is what your EVM understands. That is the first thing your Solidity contract will spit out. Let's try it out really quickly. Remix is a online Ethereum IDE, just like Replit, where you can write some code and compile it and look at the ABI. So if you go to remix.ethereum.org, it will give you a very fancy interface like this. On the left, it will give you some starter files. One of those files is storage.sol. For me, it looks a little different because I was playing with it a while back. But if I open it in incognito, you will see contracts storage.sol, very similar to the thing that we just saw. Defines a variable called count. Lets me construct the variable or initialize it to 0 in the constructor. Increases it by 1 in the increment function, decreases it by 1 in the decrement function, does a check over here कि यार count should be greater than 0. अगर 0 से कम है तो stop this transaction right here. And then a function called getCount that returns the count. Very simple Solidity contract. You can make it simpler if you want. But what are we trying to understand? What happens when I pass this through a compiler? What happens when I go to click on Solidity compiler on the left? Click on compile. one_storage.sol. Compile this file. And what does it spit out? It will spit out two things for you. The ABI and the bytecode. Bytecode is what we're focusing on for now. Copy the bytecode. Paste it here. You will see a very long hexadecimal string. Do we remember hexadecimal from the beginning? What was hexadecimal? If I want, I can convert bytes into hexadecimal format. If this is the bytes that I have, 0010. These 4 bits is what gets converted to the first character here. Let's say 2, because 0010 when converted to a decimal is 2. And then the next 4 bytes, 1100. What is 1100 when converted to decimal? It is 4 plus 8, 12. What does 12 look like in hexadecimal? 12 in hexadecimal looks like 9 is 9, 10 is A, 11 is B, 12 is C. So the hexadecimal representation of 0010, 1100 is 2C. you can convert this binary into a hexadecimal representation. Similarly, here is a very long hexadecimal string which you can convert to bits if needed, can convert to hexadecimal if needed. This is my ABI, very long complicated string that I can copy from here. The byte, sorry, this is my bytecode, not my ABI, this is my bytecode. So if you have Solidity code, you can convert it into bytecode. This bytecode is what gets deployed to the Ethereum blockchain when you publish a smart contract. When you publish a smart contract, you are not sending them your Solidity code. What gets stored on the blockchain is just the bytecode. You can click on this button. If this is a simple contract that you have, you can compile the contract and then copy the bytecode over here. It'll spit out a string of zeros and ones. Do we understand Solidity and bytecode? ये bytecode है जो EVM understand करता है. Next, we will dive deeper into opcodes, which is, us trying to now understand. Where did it go? The slides are messed up. Did one of you have edit access or what? I don't know. We'll try to understand this very long string. Okay, अंदर से what does it mean? ठीक है, this is a bunch of bits. The computer understands these bits. The computer executes your contract. वैसे तो you don't have to understand it. Never do you understand this for a C++ program or a Java program. कि अच्छा, what does this bytecode really represent? But it's good to know for Ethereum or any language. If you ever want to reverse engineer a binary, you can reverse engineer by the steps that we're going to follow now while we understand about opcodes. So do we understand Solidity and bytecodes? Can I move on to opcodes next? Can we do a quick poll? %91% is beautiful. Let's move on to opcodes next. This is a hard concept. If you have done compiler design in school, I don't know, if you had those assignments where you literally had to read through the opcodes and write assembly code, then you probably might find this interesting or easy. Else you will find it hard, but we'll still try to understand this as best as possible. This gave you this very complicated string. This is actually a series of opcodes. Opcodes in Solidity Ethereum virtual machine context. Opcodes in Solidity's Ethereum virtual machine context are low-level instructions that the EVM executes. When you give the Ethereum virtual machine something like this, it understands कि the first दो number जो हैं यहाँ पे, the first byte maps to an instruction कि ये कर भाई. The next two bytes might map to an instruction, might map to some data, but all of these bytes, it is hexadecimal. First 4 are 6 is 4 bits, 0 is 4 bits, so on and so forth. So 60 is 1 byte. This byte represents an instruction in Ethereum, an opcode in Ethereum. Each opcode corresponds to a specific operation such as arithmetic, data manipulation. What is arithmetic? कि a plus b कर दो. What is data manipulation? कि change the value of a to something else, some variable to something else. Each one of these opcodes is how your arithmetic is actually happening. इनमें से one of these opcodes is add. Add means कि भाई इन दोनों numbers को add कर दो. तो whatever high level code that you're writing over here is actually getting converted into a bunch of opcodes. Somewhere here is your function. यहाँ पे कहीं आपका add function है. That add function, whenever you call, those opcodes are what are running one by one and calculating the sum. ये जो EVM है, the Ethereum virtual machine, is doing nothing but executing these instructions that are written in that function. So if there is a function over here that you call eventually, nothing happens. These instructions start to run one by one, and that is how your whatever sum is calculated, value is updated, all of these things. When you write a smart contract in Solidity, it is compiled into EVM bytecode, which is a series of these opcodes. This EVM bytecode, very long string, is a series of these bytecodes. Let's try to see some of these, a series of these opcodes. Let's try to see some of these opcodes. A series of these opcodes. Here is a website that you can go to. There are a bunch of tools like this that exist for every languages for reverse engineering binaries. For reverse engineering के अंदर तू कर क्या रहा है भाई? What exactly are you doing in this binary code? If you're what do you call it, information security hacker, if you ever go to a CTF, This specific tool is only for decompiling, EVM binaries or bytecode, but you can decompile Java code. You might have heard I'm decompiling an APK, an Android APK to figure out where are requests going, trying to hack an Android application. So if you are ever not given this code, अगर आपको एक hacker ने ये code नहीं दिया, so you can't look at the code and understand what is happening. You can decompile the binary and look at these op codes and try to understand what is happening. For that, you need to also understand what does an opcode do in this specific, operating system. In this virtual machine, ये opcode करता क्या है? What does push1 opcode do? What does mstore opcode do? What does call value opcode do? ये opcode actually में करता क्या है? You need to understand this. Only then can you reverse engineer a binary. If you go to evm.codes and try to paste your bytecode, it will spit out all the instructions. And notice, the first 2 bytes over here, 60, points to this push1 opcode. What does push1 do? We will get to. But this 60 that is mentioned over here is nothing but an operational code, an opcode in Ethereum. Harkirat, how do I know 60 is this opcode? You can go to evm.codes. If you go to evm.codes, it will tell you 00 is the stop opcode. Now what does stop do? We will get to. What is the 01 opcode? Add. Can you guess what add does? It adds 2 numbers. Multiplies 2 numbers. Every program can actually be converted into some of these opcodes. These opcodes will do everything that you can write in a program. So this is like an exhaustive list of opcodes that you need to run any program. As the high level developer, you never worry about this. ये तो compiler समझेगा. ये तो virtual machine समझेगी. The virtual machine will understand these. But under the hood, it's just a bunch of instructions. If I go back here, the first 2 bytes were 60. What is 60 over here if I see? 60 is push1. What does push1 instruction do is a different question. But what is 60 over here? Push1, which means you can always decompile the bytecode and hope to understand what is happening. Of course, it is very hard to do, to reverse engineer what happens here, but you can do that. 80 is probably the real number 80. It's actually, not 80, this is in decimals. This is the hexadecimal representation of it. But 80 over here does not belong to an opcode. So it is the actual number. Okay, I'm trying to push this number somewhere. Kahan pata nahi, but I'm trying to push this number somewhere. We'll come to where it gets pushed. Then 60 again. What was 60? Push1. Oh, oopsie daisy. Then if you look at it afterwards, there was 40 over here. So 40 is the number that I'm storing. If the next instruction was add, can you guess what would have happened? Push karo 80 ko kahin pe. Somewhere push 80. It gets pushed onto a stack. We'll come to this. Push somewhere 80. Then push in the same place 40. And then if the next thing was add, then you would have been adding 40 and 80 equal to whatever is the total. It won't be 120. This is not decimal. This is hexadecimal. But whatever is its sum is what will get stored somewhere or, get replaced. We have a very nice visualization of this in the end, where I will explain what is push1, what is mstore, what is add. So don't worry if you don't understand the exact opcode, but every binary under the hood gets converted into these opcodes. You can always take your bytecode and look at the actual opcode. Somewhere in these opcodes, your functions are there. This though is something else. The first 4 instructions are for, contract initialization, for doing something else, for storing the contract, some data in some contract. बाद में जाके कहीं is your real code for executing a function. Somewhere here, let's say. And when you call a function on a smart contract, those instructions are what run under the hood. Push1, for example, is one instruction. If you look at this website, it also shows you minimum gas. It shows you कि आपको ये instruction अगर run करना है, you need to spend 3 units of gas. 3 is very less because this is a very simple instruction. We'll come to what this does very soon. If you look at a more complicated instruction like store, 100 amount of gas you have to dispense or pay to call this store instruction. Can you guess what this store instruction is? It's for actually persisting data on the blockchain. जब मैंने ये लिखा था in my smart contract, what did I write a while back? I wrote count plus equal to 1. I was updating data on the blockchain. Whenever you store a variable on the blockchain, storing a variable on the blockchain, getting the variable from the blockchain, sload. There is another EVM code here called sload.
Notice it also takes 100 amount of gas because you are literally reading from the blockchain. Very expensive operation. So I will have to first S load, spend 100 gas. Then I am updating it somehow using some opcodes. Then I will call S store to store it. So these instructions will run one after the other. And that will calculate how much gas I have to pay. So if you're reading from the blockchain, I'm reading the count variable from the blockchain. This isn't an argument. This is being read from the blockchain. If it is being read from the blockchain, then it's very expensive. What instruction does it use? What opcode does it use? It uses the S load opcode. And what opcode is used to store back data on the blockchain? The S store opcode. Both of them are the most expensive ones here. 100 and 100 because reading from the blockchain extremely expensive, writing to the blockchain extremely expensive. That is what is bytecodes. Here is the list. If you want, you should go through this. If you really want to go through this, you should decompile a C++ binary. And there are a lot of challenges in these CTFs to reverse engineer binaries. Most of them are written in C to trigger a buffer overflow, if you have heard of it. Very common CTF challenges. Okay, there is some data stored somewhere in the binary. You have to pull it out by triggering a buffer overflow. There you also reverse engineer these binaries. In Solidity, rarely will you use it. Most Solidity contracts, if I went to Etherscan a while back, this contract ka code I can read directly over here. This isn't stored on the blockchain. This is stored on Etherscan. But most good contracts will give you the original code as well. So you can just read through it. You don't have to decompile the binary and try to understand what is happening here. This is the deployed bytecode. If I want, I can, decompile this bytecode and try to understand. Acha, kya ho raha hai? This is the complicated opcode list that comes out. But high level code hai to. These people have at least given out the high level code. So I can just read through the high level code and understand how does this USDC contract work. क्या कोड लिखा गया इस कॉन्ट्रैक्ट में. बिफोर आई इंटरेक्ट विद इट, आई कैन रीड थ्रू इट एंड अंडरस्टैंड व्हाट इज हैपनिंग ओवर हियर. दिस इज अ proxy contract, for those of you who know what a proxy contract is. All right, cool G. That is what is opcodes. Do we understand opcodes? The bytecode is nothing but a list of opcodes. They run when you deploy the contract, when you call a function on the contract. And we'll be going through some of these opcodes soon to see a visualization of what happens when you call, let's say, a simple function. Let's do a quick poll. Cool. 85% is not bad. One thing that's left is ABIs. Let me do ABIs. Then let me do a very nice visualization of opcodes. Then we can call it. The only thing that will be left is the EVM architecture. Very simple, very high level stuff. High level as in, very theoretical stuff, which we can do also at the end, or we can do an offline video for. ABIs, let's do though. They're important. As I said, Solidity ke baad the most important thing is ABIs. Application Binary Interface. I think I could be wrong. Google it. I think it's called Application Binary Interface. Could be wrong. Google it. It is in Ethereum, ABIs is a standardized way for interacting with smart contracts. Very jargony statement, but it will become clear very soon. It defines how data should be encoded and decoded when it is being sent to and from a Ethereum smart contract. भाई ये आपका smart contract था. It got converted into bytecode. Bytecode got deployed. How will a JavaScript developer interact with your smart contract? How will he write the code to call the add function over there? By looking at the applications binary interface. इस application की जो binary बनी है, whatever was the bytecode that got spit out of it, what is its interface? क्या क्या function है वहाँ? What all functions can I call over there? It is just a very big JSON object which stores कि यार ये यहाँ पे ना there is an add function. This is the first input to this add function. It is called A. It is of type uint256. It has another argument which is of type uint6. It is called B. It has a function name called add. तो what is an ABI? आपके कॉन्ट्रैक्ट को बड़े अच्छे रीडेबल फॉर्मेट में कन्वर्ट कर देता है, जेसॉन में कन्वर्ट कर देता है. इट कन्वर्ट्स इनटू अ वेरी नाइस जेसॉन, सो यू कैन गो थ्रू इट एंड अंडरस्टैंड कि अच्छा दिस इज व्हाट द बाइनरी एक्चुअली डज. यू कैन ऑल्सो रीड थ्रू दिस एंड डू इट, राइट. तुम कहोगे हरकीरत आई विल जस्ट रीड थ्रू दिस एंड अंडरस्टैंड एड. वाई डू आई नीड अ जेसॉन? बिकॉज जेसॉन एवरी लैंग्वेज कैन अंडरस्टैंड. आप जावा में भी जेसॉन लोड कर सकते हो. इन गोलैंग यू कैन लोड जेसॉन. इन जावास्क्रिप्ट यू कैन लोड जेसॉन. You can't load Solidity in Java and try to figure out, अच्छा, there is an add function. You can't load Solidity in JavaScript and figure out, oh, there is an add function. There are parsers you can do it, but very complicated. Very simple here. JSON object, इसको load करो and you can identify, अच्छा, add is a function, these are the two inputs for it. What is the use case of an ABI? This is one of the recently head of Solana Devrel tweeted ke, this is how Solana would look if everyone posted their ABIs. What did he mean by that? He meant कि यार वहाँ Solana में भी सब लोग अपना कोड डाल देते हैं. People push their smart contract, forget to push their ABIs. तो समझ ही नहीं आता how do I deploy with this smart contract. अब यहाँ पे if I am in this remix in Etherscan, this is my smart contract. If I go to compiler over here, try to compile it, then there is a step to deploy and run. There is a step to deploy and run. If I click over here, click on deploy, तो मेरा contract deploy हो गया. Over here, I can see my deployed contracts. I can see my contract is deployed, not on Ethereum, like some local blockchain. But notice, 3 बड़े बढ़िया button आ गए. Decrement, increment, get count. I get 3 buttons over here. How do I get these buttons? Through the ABI. इस contract की ABI, if I open this specific contract's ABI, it looks like this. There is a decrement function, has no inputs. There is an increment function, has no inputs. There is a get count function, has no inputs. So that way, I can programmatically create UIs like these. I can test these specific smart contracts using the ABI. It is just a very big JSON object that gives you the structure of your smart contract. This is one function over there. This is one function over there, so on and so forth. Cool. That is what a application binary interface is. What is it? Application की जो binary है उसका interface क्या है? What does the interface look like? How can I talk to this smart contract? What functions exist in this smart contract? That is what a ABI is. I don't think we need a poll here. I think we're good to go. Let me first take you through a very nice visualization of opcodes and some smart contracts running under the hood. Then we can understand the architecture of EVM. All right. Oh, well, little bit we will have to understand the architecture of EVM also here. Let's do that. Not too difficult. Yeah. And also not super important also. Only the stack part is important. This thing right here. Everything else, even if you don't understand for now, it is fine. Last section for today, bear with me for, we're at 9:40 already. Let's finish it, guys. 10 minutes, I promise. And happy to do a recap after. Architecture of EVM. एक मिनट यार, मैं poll कर लेता हूँ. Let's do a poll. If you guys are fatigued, there's no point. No one will learn anything. Can we do a quick poll? Can we proceed? Oh, fuck. Should have asked, let me ask the question, bro. But let's say the question is, shall we proceed? And the answer is yes. So we will proceed. And if you're drained by now, you can come back to the offline video. I'll try to take it slow and understand the architecture of the Ethereum virtual machine. Specifically, the things we want to understand are memory, storage, and contract. Memory and storage, and maybe stack. Alrighty. The clients that I showed you a while back, the Ethereum client, I was saying there is a Go Ethereum client, the C++ Ethereum client. They all implement code like this under the hood. They have this concept, or they have this variable called stack. They have this variable called memory. Account state is not the world state. World state is something else. They have something called the account state, जहाँ पे कुछ store होता है. Gas available is a field that they have whenever a smart contract is called. Program counter and a ROM, or the random, what is it called? Read-only memory. ROM is read-only memory. This isn't not your machine's read-only memory. This is the architecture of the virtual machine. Ethereum virtual machine under the hood looks something like this. Program counter, I totally forgot what this does. This is again, does it in various, you'll find this in various virtual machines, or even, your normal machine CPU has this concept of program counter. If you've heard CPU, or if you've done CPU architectures in school, I think it's used for, where it tells you where you are in the program. I could be wrong. This part we will Google again. ROM, or the read-only memory, ROM, is a place जहाँ पे आपका smart contract code. Let me just go to the next slide. This is the architecture of EVM. We'll get to what these parts are. This architecture becomes relevant for us when we are sending a transaction. Whenever I'm calling a smart contract on the Ethereum blockchain is when we will understand what this specific architecture does, what is the stack used for, what is the memory used for. So when you send an instruction or transaction on the Ethereum blockchain, this is what you send to the Ethereum blockchain. You send कि यार दिस इज द स्मार्ट कॉन्ट्रैक्ट आई वांट टू इंटरेक्ट विद, अनलेस यू आर सेंडिंग समवन नेटिव इथेरियम, तब तो कुछ और है. आप इफ यू आर ट्रांसफरिंग इथेरियम फ्रॉम यू टू योर फ्रेंड, different thing gets called. But if you are calling a smart contract, you will have a to field, which is what smart contract I want to call. The data field, which will be मैं कौन सा function call करना चाह रहा हूँ, sum function, get count function, set count function, and what are the inputs that I want to send in here. This is the second thing that you send in the transaction object. Gas limit, the maximum amount of gas you are willing to spend. Very important, not very important concept, but like an important concept, because in Ethereum, this virtual machine is single threaded. This virtual machine is single threaded. ये एक बारी में एक ही transaction run करती है. It only executes one transaction at a time. That doesn't happen on Solana. On Solana, transactions run parallelly. That is why it is a faster blockchain. In Ethereum, they run sequentially. So there is a gas limit. कि यार this is the maximum amount of gas I want to spend. And अगर आपका program execution is taking a long time, if the smart contract that you've called is taking a lot of gas, doing a lot of opcodes that exhaust a lot of gas, and your gas limit is reached, your transaction will be aborted. तो ऐसा नहीं है कि you can call an infinite while loop on the Ethereum blockchain. If you call an infinite for loop, you will have to give some gas limit कि मैं इतनी Ethereum spend कर दूंगा. All of that gas will keep on getting executed as the compute flows. And if the infinite for loop is running, eventually the gas limit will be reached and your program will stop executing. Otherwise, someone can come and block the Ethereum blockchain. Ethereum blockchain is single threaded. एक बारी में एक ही transaction रन हो रही है. So every transaction पे you give a limit कि इतना Ethereum I will spend as gas, and if more gas is exhausted or exempted, then that transaction stops. Gas price. How much are you willing to pay for every unit of gas? This into this is the real Ethereum that you pay. This is the limit कि इतना गैस खर्च हो जाए कोई बात नहीं. This is how much Ethereum I am willing to spend per gas unit. This number might be 0.001. So I'm willing to spend 0.001 gas for 1000 gas limit, which means I'm willing to spend up to 1 Ethereum for this transaction to happen. That is the actual Ethereum that I spend. तो जब the blockchain is clogged, देखो gas limit तो can be calculated, right? You know what instruction you are running. आपको पता आपने sum ही run करना है. You know the sum instruction takes 20 gas. तो gas limit तो you can set to 20. क्योंकि मुझे पता है the instruction that I'm calling is a simple add function. It only takes 20 amount of gas. But gas price is something what people compete for. कि I will pay more for this gas. I will pay more for this gas. For 20 amount of gas. So the person who bids the most is the person that the miners will pick. Nonce, a number indicating the count of transactions that you have sent from your account. EOAs, externally owned accounts, have a nonce. आपका जो nonce है वो आप साथ में बेचते हो. This is the number of transactions that I have done until now. And a value, which is if you want to send some Ethereum along with it, you send this in your transaction object. So this is what the transaction object looks like. If you're doing a simple transfer, then a lot of these fields don't make sense. Only the value field and to field makes sense. If you're calling a smart contract, then again, maybe just these fields make sense. The value field doesn't make sense. If you're just trying to increase the count, you don't have to send any money to the smart contract. But if I'm trying to do a swap, then I have to send one Ethereum to the smart contract so that it can return me some money, right? So this value field will be if I want to send some Ethereum to the smart contract. All right. So that is what happens when you are calling a function or doing a transaction. When the transaction is picked by the specific virtual machine, आपने transaction भेजी. If you remember a while back, I said it reaches the mempool. If that gets picked by the mempool, if that gets picked by one of the that specific miner, then the execution begins. Then number one, from this world state जहाँ पे सारे addresses हैं, सारे accounts हैं, your smart contract code, bytecode gets picked and put over here. Read only memory. I don't want to update the user's smart contract. I just want to get it over here so that I can quickly access the functions inside. You get this specific, bytecode in ROM, read only memory, and then the specific function call executes. अब ये है the simulation that I wanted to show you, which will include the stack, the account state, and the memory. This is the world state. This is different. This is the account state. Okay? Currently, this specific account में क्या क्या data है ये is specific. If this is an Uber contract, the account state is all the rights, things like these. So this specific account का state, stack which is initially empty, memory which is also initially empty. The specific function call executes. Let's say the function that I called is a sum add function. This is my contract. Simple add function over here. It has a byte code. I call the add function over there. When I call the add function, the opcodes that are running will look something like this. Here we will learn a little bit about the opcodes. What were opcodes? All of this data that, these list of opcodes that exist on the Ethereum blockchain or EVM. We did not understand any of these. Even though high level, we understood that add probably adds two numbers, mul probably multiplies two numbers. Now let's see, in actuality, this is not exactly what happens, but close to what happens when you call a simple add function. सबसे पहले, the first opcode that gets called is call data load. Call data load will load the very first argument on the stack. Here is a super important concept. EVM is a stack-based virtual machine. EVM is a stack-based virtual machine. Harkirat, what is the other type of virtual machine? Register-based virtual machine. If you have done compiler design in school, you might remember registers R1, R2, where you store data temporarily. Here, you store data in a stack. तो जो भी instructions होते हैं, sum हो रहा है, multiply हो रहा है, some complicated swap is happening, all happen via variables on this stack. Call data load will take the first argument, push it on the stack. Call data load again will pull the second argument, push it on the stack. Let's say I called this function with 2 and 3. Then this is what the state looks like right now. It is a stack. First in, last out. तो पहले 2 गया, फिर 3 गया. Then add gets called. What does add do? It pops the top 2 elements, adds them up, pushes it back. What does it do? ये दोनों निकालेगा, इनका sum करेगा, वापस डाल देगा. That is what the add byte goes or opcode does. And lastly, we will return this value from this function. The stack will become empty. We did not have to touch the account state. We did not have to touch the memory. सिर्फ stack में हमारा काम बन गया. This, well, there are more, but a very simplified version of what opcodes run and under the hood what happens. And if you go through the code base of one of the clients of Ethereum, you will see there's a stack variable where you're pushing these elements. But what are machines, computers? Nothing. They just run a bunch of instructions. You tell them, the developer tells them what to run. Machine तो उसको बस execute कर देती है. This is how Ethereum executes them using a stack-based virtual machine. सारी multiplications, divisions need to happen via stack, and it is possible. You might think that stack है. What if there is a variable below that I want to access? It is possible. You will still be able to create a bunch of opcodes that will let you access this specific thing, add it to another function, variable, whatever you want to do, and return it from here. So here is a simplified version of 4 opcodes that run, and this is what they do under the hood. Let's look at one more contract that touches the world state. If you remember, the world state is this thing right here. Basically gets some data from here, updates some data over here, things like these. So here is another counter contract. Constructor initializes the value to 0, increment increases the value, decrement decreases the value, get count returns the value. Kudos to everyone who's here. 2 hours and you guys are still here. Beautiful, love you guys. So यहाँ पे let's look at the increment function. When I call the increment function, what happens? The increment function will have opcodes that look like this. Here comes the push 1 opcode, if you remember. Push 1, we saw this a while back also. 60 था इसका, hexadecimal representation was 60. What will it do? Push 1 pushes a number on the stack. So push 1 0x0 will push this number on the stack. S load, storage load, will pull जो भी 0th position पे यहाँ पे है ना, यहाँ से उठा के यहाँ ला देगा. What will S load do? कि इस contract की 0th memory पे जो present था, not in the world state. World state से पहले data account state में आ जाएगा. सबसे पहले, when the code is coming over here, the data for this account will come over here. And उसकी 0th position पे, मान लो, assume कि this count variable is stored on its 0th position in memory. So what are we saying? कि भाई 0th position, first is push 0 over here. Then S load will pull whatever is present in the 0th position in the stack. It will pop this off, pull the value over here. Now count was initialized to 0. तो यहाँ पे 0 ही आएगा इसके बाद भी. 0 will get pulled over here. Then we push 1 to the top because I want to increment it by 1. I push 1 on the top. Then I call the add opcode. What does add do? Pops off both of these, pushes it back, and then push opcode will again push 0 over here. And then I will call s store, which will take this value and put it in the 0th position. What does s store do? जो इसके बाद आने वाला है. S store takes the value, ऊपर से जो second value है, puts it in the 0th position, puts it in this position right here. That is how we update the account state, which of course gets reflected in the world state eventually. First time के बाद this account state will hold 1, that will get stored on the blockchain. What if we call increment again? अब क्या होगा? Again 0 will get pushed here. S load will take whatever is present in the 0th position, pull it over here, 1 will come over here, then I will push 1 over here, then I will call add will take both of them, pop them off, push the added value, push will push 0 over here, and then S store will take this value and put it in the 0th position or the 0th address, which is the first address right here. All of this is assuming that the count variable is stored in the 0th value here in the account state and in the memory. That gets propagated to the state eventually. One more thing I haven't talked about is this memory section, which is short-term memory, which basically means यहाँ पे whatever you store does not reach the blockchain. यहाँ पे whatever you store dies as soon as the transaction is finished. It is wiped off after the contract call is done. Usually used for storing temporary arrays and corrections. यहाँ पे usually arrays and corrections आते हैं. Numbers are stored here only. Even if you create some temporary variables, they are usually pushed on the stack only. They are not stored here. Things like arrays will get very complicated to push here, which is why they get stored here in memory. That is the architecture of EVM, and most technically the opcodes, how they run when you call a function. How are we doing? The people that are left, still a decent bunch of people. How was the class? Did you guys understand the class? Thoda zyada ho gaya. It's almost 10, 2-hour class today, but thankfully, the abstract part is done, implementation is left. Yeah, hopefully that is good. I read the Uniswap v3 code. I have not. So let's see. According to me, they don't write code to convert ETH to VETH. Is that converted ETH to VETH in frontend or other method? I don't know. You have to convert it to VETH, right? Are you sure? Maybe what happens is, and I haven't read through the code, but I totally get why a swapping, a DEX would want to have some other ERC20 token rather than, the native token. The logic can be very well abstracted if you are using ERC20 tokens for everything. Agar most of the logic is for ERC20 tokens and then some logic is for the native ETH token, things get really complicated. So do you see any native token specific code there? When you read the v3 contract, did you see any code that is native to Ethereum? And if not, that means that udhar they assume you are going to send VETH, and as you said, the ETH to VETH conversion happens before. So you first convert your Ethereum into an ERC20, which has a similar value or the same value, and then you pass it through Uniswap v3, jahan pe all it has to do is swap 2 ERC20 tokens. It doesn't know that one of those tokens is actually, one of this token is native Ethereum. All right. Poll kar liya jaye. One poll and then we will officially end the class and do Q&A. One last poll. Did you guys understand everything or some things? And baki aa jayenge recording mein, later on. Did we understand? How was the class? Do you good? Let's see. 83%. 80%, 81%. Scope for improvement. Not a lot of people are voting also. ठीक है जी. Time for Q&A. I'm going to share my screen. Let's do Q&A for some time. Let me open the browser. And so I'm just looking at chat now. And you guys have already asked questions, some Notion docs. From what I understand, EVM architecture is setting scalability aside. It doesn't seem too difficult to build. Oh yeah, 100%. 100%. I mean, building EVM is probably hard. Building a virtual machine, like a smaller one that only supports 5 opcodes might be easy. Building the whole thing might not be too easy, but yes, doable. And as you said, one of the reasons being that single threaded doesn't care. One transaction after another. If you apply the same logic to Solana, you can't apply the same logic to Solana. Solana is much more harder to, look at code. if you look at a transaction in Solana, you have to send the accounts that you're interacting with. That is what lets you, paralyze transactions. So you have to take care of a lot of things. Versus, as you said on Ethereum, fairly simple. The transaction object is so simple. The transaction object on Solana is extremely complicated. You have to give it 10 different things. So yeah, I got a bit too much. Oh, that's good. It got a bit too much, yes. But thankfully, abstract class. Keep coming to it before your interview. Focus on writing smart contracts that will come from the next class. This is your pre-interview checklist of, how does EVM work under the hood. ABI again, please. ABI, Application Binary Interface. नाम में ही सब कुछ है. The name itself has the answer. It is called Application Binary Interface. This is my application. मैंने लिख दी. बहुत बढ़िया एप्लीकेशन है जी. मजा आ गया. Very nice smart contract. I converted this into a binary by compiling it. I got some byte code which was binary code. हरकीरत ये binary नहीं है. This is binary only. It doesn't look like it is binary, but it's just binary converted to hexadecimals. So this, lot of very long string that you see can actually be converted to zeros and ones only by, converting hexadecimal into binary. So I have my application. I have its binary. I need a application की binary का interface. कि यार I've just copied this. I don't understand anything by looking at this long string. इसको देख के तो कुछ समझ नहीं आ रहा. What all functions exist here? I don't know. How can I call those functions? I don't know. But if I look at this, can I tell कि अच्छा there is a decrement function there. That function that is of type function. Get count that is of type function. And this thing returns you an integer, things like these. So, ABI आपको बताएगा कि binary दिखती कैसी है, अंदर क्या हो रहा है, what is happening inside the binary. That is what an application binary interface is. All right. What else did we have? Chat. Can you tell me why push second last? Why don't we need push 0 before starting data? Can we tell why we need push second last? Why do we need push 0? Yes. Great question. Because the store opcode को दो चीजें चाहिए. What value do I want to store? Where do I want to store it? Do I want to store it at the 0th position? Do I want to store it at the 5th position? Where in this account state do I want to store it? So store expects two things to be on the stack. The data that you want to store and where do you want to store the data. जो ऊपर है, that is where you want to store it. जो नीचे है, the thing that is below, is what is the data that is being stored. Why did you take a pair of 2 for opcode? Why did you took a pair of 2 for opcode? What does that mean? Why did I took a pair of 2 for opcode? Can you ask that question in a more elaborate fashion once? Let me open chat one more time. And I've opened all the Notion docs as well. I'll go over them one by one. Alrighty. Let me start from the top. ABIs are similar to IDLs in Solana. Yes, I was looking for the word. I was saying IDL. Yes. What is the full form of IDL? But yes, so ABIs are similar to IDLs in Solana. I am a tier 3 student. Okay. Oh, 200% hike with good MNC. Great. That felt like a very sad message and eventually became a very good one. Cool, man. Let's talk. Ping 100x devs Twitter. Let's do a podcast. Do you know about Nethermind? No idea. Oh, is that a ETH implementation? What is it? And is it worth to work there as I don't know what it is unless I have these people built one of the clients on Ethereum. I don't know, maybe. We enterprise developers looks pretty legit is all I will say. Yeah, exactly. These are the people who've built a client for Ethereum. Why would you not work for them? I don't know. Maybe their client is outdated or whatnot, but yes, I would work for them. What language have they written on? I remember this from a little bit. Netherlands was another implementation. What language is it in though? C#? Don't work there. I'm kidding. Yeah, it's fine. Everyone has their own, languages to write code in. Seems like they've written it in. C Sharp, which is fine. Yeah, I would work there. It'll teach you a lot about, ETH. I build a front end and build back end when it comes to and if you're not going, refer someone else. It's a great opportunity to work there as an intern. I can interact, build many projects, can't interact, one hackathons. I build front ends. So is there a question there? What are hooks in blockchain? I have no idea. I've read through them. Probably things like, I don't know, let me not guess, but I would assume something like catching on to events. Hook being, whenever something happens on this contract, send me a notification. I could be wrong. So, Google it. Can you write tests too for smart contract? You can write tests for smart contracts. They don't run on the blockchain, but locally you can run tests for, an Ethereum smart contract. The following video hackathon project we created for Python, but the data server. Sorry, I don't understand this. How services written in different languages, communicate. Here is an example. There you go. Someone has an example of how services communicate in different languages, where here's a hackathon project where the Python OpenCV module talks to, some other library like Unity by an HTTP server. Great. And here is a link for it. So you can follow Saras Joshi. Here is their handle on Twitter. Alrighty. Beautiful. Notion doc done. I don't know if the resume decent resume, don't worry about it. And it's very hard for me to review, what is the best way to get into GSOC apart from GSOC? GSEC is in May, tab tak kuch karna hai. A lot of people are finding them and they don't pay very well. Like 20-25K a month wali internship though is very possible. Like a lot of companies hiring, I don't know, a lot of companies, but every other company will pay this much because it's very cheap, right? So if you're okay with something like this, then if you don't want the elegant, I want 1 lakh a month internship, then you'll find service-based companies, other companies, not exactly service-based, companies that have better work also, and you can work there as an intern. Bunch of portfolios, very good. But let's review them. Let's do another session proper for these. Let's focus on doubts. You told me to make video on liquidity pools, adapters with metadata, etc. There was a voting held. Decide more offline ways Web3 live classes would be doubt. Yeah, I'm trying offline videos. इसमें हफ्ते react किया offline videos were there, so this wouldn't happen. What are you saying? Liquidity pools. Did we not discuss it last week? Akash, can you make a note? Adapter with metadata. I would assume you mean tokens with metadata or something like that. Yeah, I know there's a video that's pending on that. They will come hopefully soon enough. Let me next week focus on Solana offline videos. All right. This is done. Looks nice. Looks like a copied. A lot of people use this template. Interesting. Don't hate it. Done. I know. You sent an email. I will look at it. That backend doesn't belong to me. It'll probably take days for them to review it. That's Apex backend. Every edtech has the OTP hack. It's like everyone and their mother. 4 people, 5 people. Every edtech, maybe other Unacademy, have the OTP hack that you found. I don't know if there are others. I thought they had rate limiting. Maybe they don't. So I'll forward the talk and I'll connect you guys. You can talk. And if they don't give anything, I'll do about it. All right. Here is a question. What should the students do both in Web 2 and Web 3 and they're complete beginners? Should they just follow cohort? No, you guys should definitely do something extra. That's such a bad question. Of course you should do something extra. I mean, if you're a complete beginner, itna bhi nahi ho pa raha, then it's a different thing. But if you don't push yourself, how will you get that job? Tech is one field where you can, if you work twice, you get paid twice. You can do 2 jobs. Same for learning curve. If you work twice, your learning curve will be much harder, much steeper. So yes, you should learn more outside the class. And why would you not do that? And why is that even a question? All right, more questions here. Tomorrow is there's a scam running on X. It's running on my YouTube channel also. They'll comment the seed phrase, but it doesn't. Well, how do they do this? Yeah. So what happens is they actually have USDC on that specific Ethereum wallet. So you feel like, "Arey, mil gaya paisa." This account has USDC. It doesn't have Ethereum though. So you can't pull money out of it because you need Ethereum in there for gas. So you send there some Ethereum for gas and they pull it out immediately. They have, code running very close to the miners. Most of these are people who are running their own, these things, miners. So they sit very close to the blockchain. And tum wahan Ethereum daloge ke let me pull out that USDC. Whatever Ethereum you put in, jitna bhi hoga 0.01 for gas, they pull it out. So that's how that scam works. It's a legit scam. First time you open it, wow, I got 900 USDC. But actually, that 900 USDC you cannot move because there's no gas in there. As soon as you put gas, they pull out the gas. Launching an NFT for Web3 company is not similar to IPO for Web2 company. There are a lot of regulations that happen in Web 2 and Web 3 when no one cares. Most NFTs, there is no bandish on the founders to do anything, and they also can't do anything. Like it's not what do you call, what's the word for it, regulated, this industry, right? So you can't be like, I'm opening a company and iske sare dividends are going to go to people who hold my NFT, because you've effectively created an asset, and you can't create assets out of thin air that people can trade on. So if anyone says, that's why people say our NFT has no utility, our NFT does nothing, because if you say our NFT does something, then you're legally bound. If you're at least in the US or India, and most NFT founders are in the US, so they shy away from it. All right. Cool guys. There's someone who said opcode and ABS को recap कर दो. ABS कर दिया, opcode एक बार पढ़ो भाई मेरे भाई. Go through the video again and then go through some other videos. Try to understand them again. If you don't understand it, I will take one-on-one session with you. But let me tell you, little bit if you Google after the class, you'll be good. All right. Cool guys. With that, we'll call it 10:08. Not too bad. Good educational class. And thankfully the worst parts of Ethereum done. Now are the good parts. So we'll call it here. Some more docs I will look at that came. Baki sab logo good night ji. And let's see. Hopefully Notion docs are class related. Let's see. 3. Telegram channel bot post videos. Yeah, I know. I mean, of course I know, but like, there's no easy way to stop them. And whatever there is, I've done. Suppose it doesn't mean no. Yeah, it means it will only calculate one transaction at a second. Doesn't mean it can't use multiple cores. Maybe it does some. There are a bunch of things that are happening. There's a mempool you're pulling transactions from. They might happen on different cores, but what do I mean when I say single threaded? I mean one transaction gets processed at a time. Yes, you will only recalculate the world state by one transaction at a time. That is why people say Ethereum is so slow. Suppose that I am making a call to a function in a smart contract from JavaScript, then whose job is it to listen to that request, actually execute the function? You send a transaction object where you have signed the transaction to an Ethereum node. It gets stored in the Ethereum mempool. Then based on how much gas you're paying, they will pick it up from the mempool and execute the transaction. Do miners actually listen to my JavaScript? They're not listening to a JavaScript call. No backend system can listen to a JavaScript call. You send an HTTP request. You send over a signed transaction object to them. You send over them some very big binary that is a signed transaction of yours. It goes into their mempool. From their mempool, they pick. Never can you call a function and a backend can listen on it. You always send an HTTP request, WebSocket request. Some way you communicate to the server. Explain Ethereum clients again. Also, what is the client created by? I think it's this CPP client is created by Ethereum, by Vitalik. I think I could be wrong. Go client I think is created by Paradigm. Again, I could be wrong. Like Paradigm did create one big Ethereum client. I think they're trying one on Solana as well. Paradigm is one of the biggest VC firms in crypto. I think they created Geth, the one in Golang. I could be wrong, like Google. And the point of this is कि Ethereum का जो core code है, जो miners run करते हैं, that code is being written in various different languages, so that if one of those languages, one of those implementations has a bug, someone else will fix that bug, and other implementations won't have that bug. Some people will be running some implementations, other people will be running other implementations. So some part of the blockchain will get hacked, or whatever will run the bad code, but hopefully not the complete blockchain is running it. So 90% of the blockchain is fine, which means we're good to go. So that is why you should have multiple clients. This is nirvana for any blockchain. Any blockchain that is matured, उसका step 2 यही होता है कि they now invite more and more people to build Solana clients. Ethereum खुद पीछे हो जाता है, Solana खुद पीछे हो जाता है कि भाई मैंने प्रोटोकॉल लिख दी, मैंने पहला क्लाइंट लिख दिया, now don't trust me, I am out, I have too many bags, I will screw you over. So anyone create a client. Literally, even Vitalik doesn't control Ethereum right now. Even if he pushes something on the Ethereum main code, other implementations won't pick it up. Vitalik can no longer hack Ethereum. So that is true decentralization कि author भी नहीं कर पा रहा कुछ. Cool. That is what I meant by that. All right, cool guys. We will call it. Have a good night. I will see you guys tomorrow. We will do some React and state management.